The first kind of function we're learning about this year is a linear function. Let's go ahead and fill out some information about linear equations. The parent function for a linear equation is y equals x. There's different forms of a linear equation. There's slope-intercept form, which is y equals mx plus b. There's standard form, which is ax plus by equals c. In this case, a, b, and c are numbers. And then there's point slope form, which is y minus y1 equals m times x minus x1. Each of these forms has a different usage, but they all graph straight lines. Let's take a look at two examples. The first line we see up here is f of x equals x. That's just our parent function. So we're going to go ahead and graph our parent function. The parent function has a slope of 1 and a y-intercept of 0. So it'll start at the origin and go up 1 over 1. So here is our parent function. It has a domain of all real numbers. We'll use that symbol to mean all real numbers. It also has a range of all real numbers because it continues into infinity in the negative y and positive y direction. Let's take a look at one of its x-intercepts. That's where does it hit the x-axis? Well, this is the x-axis and it hits it at 0, 0. It also has a y-intercept at 0, 0 because that's where it also hits the y-axis. When it's asking about end behavior, it wants to know what is each of the ends of the graph doing. Well, this left-hand side is approaching negatives, and this right-hand side is approaching positive infinity. So for end behavior, we'll say as x approaches negative infinity, y approaches negative infinity. But as the x's increase, meaning positive infinity, the y's approach positive infinity. Let's take a look at this second example, this one in green. We're going to go ahead and graph it. Here I have a y-intercept of 6. I'm going to plot a point at 0, positive 6. And I have a slope of negative 2. I'm going to plot a point at 0, positive 6. And my slope of negative 2 means I go down 1, down 2, to the right 1. There we have our line. Y, or g of x, equals negative 2x plus 6. Our domain is all real numbers. Our range, our list of outputs is also all real numbers. We have an x-intercept at 3, 0, and a y-intercept at 0, 6. Our end behavior is different from our parent function Because here, as my x's get more negative, my y's are actually getting more positive. So I'm going to write that as x approaches negative infinity, y approaches positive infinity. And if we look down here, as the x's get more positive, the y's are decreasing. So we're going to write that as x approaches positive infinity, y approaches negative infinity. I'm going to zoom out so you can see the whole worksheet. Make sure all the information that I have on this, you have on yours.